Hi everyone. From this lectures, we are going to start the second chapter of the physical chemistry, that is a surface chemistry. Already we have completed the first chapter of the physical chemistry, that is a chemical kinetics. So let us begin the second chapter of the physical chemistry, that is a surface chemistry. First of all, let us consider the syllabus of the surface chemistry. So, introduction of the surface chemistry, some basic terms related to the surface chemistry, adsorption, adsorption materials, factors affecting adsorption, characteristics of adsorption, types of adsorption, classification of the adsorption isotherm. There are two types, Langmuir adsorption isotherm and Freundlich adsorption isotherm. BET theory, only introduction, application of the adsorption. So, here this is the syllabus of the surface chemistry. Basically, in the surface chemistry, we are going to study the phenomenon of the adsorptions and the terms related to the adsorption. So, here let us consider the introduction of the surface chemistry, that is the introduction of the adsorption. So, various reactions occur at solid surface of the substance. Hence, surface chemistry research, it plays an important role in physical chemistry as well as in chemical physics, material science and nanoscience. So, here it impact on the industrial process and technology. So, here we know that molecular forces on the surface are unbalanced. Hence, the molecules experience inward pull in the bulk. Hence, due to the unbalanced molecular force, the surface of the solid have tendency to attract and retain the molecules of other species. As these molecules remain on the surface, the concentration is more on the surface than bulk of the solid. So, here when we compare the concentration of the substance on surface as well as in the bulk of the solid, so it is observed that the concentration of the molecule or the substance, it is more on the surface of the another substance. So, here this phenomenon of accumulation or concentration of molecules on the surface of liquid or gas on solid surface is called as the adsorption. So, this is the definition of the adsorption, or in another way we can define the adsorption, the collection of another substance on the surface of substance is known as the adsorption, or here the collection of the substance on the surface of another substance, it is known as the adsorption. The substance that get attracted or accumulate on the surface are called as the adsorb phase, or it is also called as the adsorbate, while the surface on which the substance get adsorbed are called as the adsorbent. So, let us consider one a simple example of the adsorption. So, here the example of, that is the adsorption of acetic acid on the charcoal. So, here when we consider the charcoal, activated charcoal, so activated charcoal it is act as the adsorbent, while the acetic acid it is act as the adsorbate. The second example is the adsorption of the sulfur dioxide gas on the activated charcoal. So, here in the second example, this activated charcoal it is act as the adsorbent, while the sulfur dioxide it is act as the adsorbate. So, here when we consider the phenomenon of the adsorption, these are the two important terms, that is the adsorbate and the adsorbent. So, here the substance that get attracted or accumulate on the surface are called as the adsorb phase, or it is called as the adsorbate, while the surface on which substance get adsorbed are called as the adsorbent. So, here adsorption is seen only liquid and gases due to the unbalanced force by attracting other substance with which they come in contact. The surface of any solid possesses active centers. So, here when we consider the any solid substance, it has a number of active centers such as the cracks, peaks, furrows, corner, edges. So, these are the active center which are present on the surface of the solid. So, here hence the molecules that comes in contact with it undergoes the adsorption. So, here friends, this is the difference between the adsorbate and the adsorbent, and here when we consider the any solid substance, it has the number of active centers such as the cracks, peaks, furrows, corner, edges. So here this point or the centers, they are act as the active centers. Then let us consider a simple diagram. Suppose if we consider the example of adsorption of acetic acid on the surface of activated charcoal. So here this activated charcoal, it is act as the adsorbent, while this acetic acid, it is act as the adsorbate. This is the first example. Let us consider the second example, adsorption of sulfur dioxide gas on the surface of the activated charcoal. Again here this activated charcoal, it is act as the adsorbent, while the sulfur dioxide molecule, it is act as the adsorbate. So here the sulfur dioxide, it is the adsorbate, activated charcoal, it is the adsorbent. Then the cases of the adsorption. So friends, there are three cases of the adsorptions are seen. The first case is gas solid. So here the adsorption of the gas on the solid surface. So here again example is adsorption of sulfur dioxide on the charcoal. So here the charcoal is the adsorbent, while the sulfur dioxide, it is the adsorbate. The second case is the liquid solid. Then here adsorption of the liquid on the solid surface. So here the adsorption of acetic acid on the charcoal. Again here the charcoal is the adsorbent, while acetic acid, it is the adsorbate. Then gas liquid. So adsorption of gas on the liquid surface. So adsorption of oxygen gas on the mercury. So this mercury, it is a act as the adsorbent, while this is the oxygen, it is a act as the adsorbate. So friends, these are the three cases of the adsorptions: gas solid, liquid solid, as well as the gas liquid. Then the adsorption versus absorption. So what is the main difference between the adsorption and absorption? The term adsorption must be carefully distinguished from the another like term, that is the absorption. So here adsorption is deposition at the surface only, while absorption is penetrate into the body of the solid. So here friends, adsorption is the surface phenomenon. So here all of you know that just we define the adsorption, that is the collection of the substance on the surface of the another substance, it is called as the adsorption. So here the adsorption is the surface phenomenon, while the absorption, it is not surface phenomenon. So here the substance is penetrate into the body of the solid. So here this is the main difference between the adsorption and the absorption. So let us consider one example here. Again, the acetic acid charcoal system. So here when we consider the acetic acid charcoal system, when the dilute solution of acetic acid is shaken with the animal charcoal, activated charcoal of the animal, the charcoal carries away some of the acetic acid. If charcoal is analyzed, it will be observed that acetic acid is concentrated on the surface of the charcoal. So here the substance which is adsorb another substance, it is called as the adsorbent. So here in this case the activated charcoal, it is adsorbent, and the substance which is being adsorbed is called as the adsorbate or adsorb phase. Again in this example, this acetic acid, it is a adsorb phase or it is a adsorbate. In the acetic acid charcoal system, charcoal is adsorbent and acetic acid is the adsorbate. On the other hand, when we consider the example of water and sponge, so here water is absorbed by the sponge and is distributed throughout the sponge uniformly. It is a process of the absorption. So here when we consider the water and sponge, so here the water is absorbed by the sponge. It is not adsorbed by the sponge, it is absorbed by the sponge, and water is penetrate into the sponge, it distribute throughout the body of the sponge. So here in the absorption process, a substance is not only remain at the surface, but it is distributed throughout the body of the solid or the liquid. So friends, this is the main difference between the adsorption and the absorption. So here the following figure gives illustration between the adsorption and the absorption. So let us consider this figure. So the first figure is the adsorption, second one is the absorption. So here this is the adsorbent, and here these are the molecule of the adsorbate. So here the collection of the substance on the surface of the another substance, that is on the surface of the adsorbent, it is called as the adsorption. So here this is the example of the, or this is the figure for the absorption. So here in case of the absorption, so this is the adsorbent while this is the adsorbate. So here the adsorbate, it is distributed throughout the body of the adsorbent, that is the substance is penetrate into the adsorbent. So here this is the main difference between the adsorption and the absorption. Adsorption, it is a surface phenomenon, that is there is a collection of the substance on the surface of the another substance, while in case of the absorption, the substance is penetrate throughout the body of the adsorbent. So, here the adsorption and the absorption. So, let us distinguish between the adsorption and the absorption. So, here again these are the two columns. So, here in the first column the adsorption, second column absorption. So, here adsorption is the surface phenomenon, absorption it is a bulk or body phenomenon. Second one is adsorption depends on temperature and pressure. That means, here when we change the temperature as well as when we change the pressure, there is a change in the adsorption, rate of the adsorption may be changes. While in case of the absorption is independent to the temperature and pressure. That means, here there is no effect of temperature and pressure on the phenomenon of the absorption. Then here third point, in case of the adsorption, accumulation of molecules with high concentration. So, here in case of the absorption, molecules are uniformly distributed throughout the body of the adsorbent. So, here uniformly distribution of the molecules throughout the body. Then here the fourth point is, in case of adsorption, adsorption is proportional to the surface area of the adsorbent. That means, here when the more surface area is available, the rate of the adsorption is more. Here in case of the absorption is independent to the surface area of the adsorbent. So, here adsorption it is the fast process, while the absorption it is the slow process. Then here in case of the adsorption, equilibrium is attained quickly, while in case of the absorption, equilibrium is attained slowly. And lastly, here the adsorption it is a reversible process, and while here absorption it is a irreversible process. So, here what is the meaning of reversible process? Whatever the substance is adsorbed on the surface of the another substance, that substance can be easily removed. So, here the adsorption is the reversible process, while in case of the absorption it is the irreversible process. Whatever substance is penetrate into the another substance, that substance cannot be easily removed. That is why here the absorption is the irreversible process. So, this is the main difference between the adsorption and the absorption. Friends, in this lecture we have considered the syllabus of the surface chemistry and the difference between the adsorption, absorption, and the meaning of the adsorbent and the adsorbate. Thank you.